Welcome to Tetryonics. In this discussion I'll give you a brief overview of the geometric reinterpretation of the maths of modern physics. It's just going to be an introductory discussion on the role of equilateral geometries and how they relate to the squared numbers that are often found within the maths of quantum mechanics or quantum theory in general, and in classical mechanics for that matter, and relativity. We'll cover a number of topics as illustrated on this, noted on this page here, but the main one will obviously be the relationship between squared numbers and equilateral geometries. The principal idea that I had when I first developed Tetryonic theory was the discovery that if you take an equilateral triangle and you put a number of them together, as you use equilateral triangles to create a larger equilateral triangle, you require a squared number of triangles. That is to say, as illustrated on the right hand side at the top, to form the larger triangle that you can see illustrated, each time you add triangles together to form a larger equilateral, there's always a squared number. For example, 1. To make the next level, there are 4. 1, 2, 3, 4. The next level requires 9. The next size up requires 16. And so on and so forth. So in this case, what was immediately obvious was the fact that squared numbers in quantum mechanics are not necessarily anything to do with a squared geometry. They do have a role to play when it comes to circular geometries, but that's with respect to a spatial coordinate, not to physical mass or matter. So this is circular squared numbers, as in pi r squared, relates to the establishment or the mapping out of an area of space in which we measure physics. But all the physics within that circular region or spherical region is comprised of equilateral triangles of mass, energy, momenta, Planck quantum as they're often termed. Now at first glance, obviously a lot of people will look at it and say, well, that's not particularly going to make physics simpler. We have a square number which is n times n, and a circle is pi r squared, but when you look at the formulations for the squared area of an equilateral triangle, you get root 3 on 2 by s squared, or half sine 60 by the length of one side, and the altitude or the height of a triangle is sine 60 square root of 3 on 2, etc. So the formulations become more complex or appear more complex. The power of Tetryonics is you don't need the math. You need to be aware of the math, but you don't need to necessarily use it. What's far more practical and of far more use is, as in the previous video in the university, is to print out the templates of equilateral quanta, the quantum coins, plus and minus charges, and physically put them together. Then as your mind becomes accustomed to the shapes and how they go together and what happens when you flip them and rotate them, you find yourself just making larger and larger square equilateral or squared energies, and then using the charges within those fields to make matter. And again, things change, hence this topic. I'm just showing you how the geometrics of Tetryonic theory differ from what you would have been taught or what textbooks would teach you. There's no need to be overly concerned about the formulations or the mathematics. In fact, I'm not strong on mathematics myself. I've done high school grade level, maths 1, maths 2, that sort of stuff, bit of when I was doing electrical engineering, but a lot of the work, and I mean 90% of it, can be done using simple paper models and just working out what the triangles will allow you to do. And that brings up a quote that you'll hear me comment on quite often as we go through all the lectures, and that is that if maths is the language of science, then geometry is its grammar. This discussion is purely about showing where interpretation and extrapolation from mathematics, pure mathematics, without a known geometric form, leads to assumptions and errors of physics, things that need to be fixed. We can fix them using the equilateral geometry of a Planck quantum. We can not only fix it, we can also correct the physics and get rid of the assumptions, and we can understand some of the greater conundrums that exist in modern physics as it's explained right now, and in fact unite the sciences. So, to give you an idea exactly what I'm talking about, the quantized angular momenta, and you'll always hear me refer to it as momenta, not momentum. Momentum is the vector force that acts on something to push it. Momentum is the square root of scalar energies. The quantized angular momentum, the QAM, is the equilateral geometry of energy. What I mean by that is that in Planck's constant, the units are kilograms square meters per second, where square meters per second is a form of angular momentum. Not momenta, momentum. Rotation about a point, if you look up the textbooks. In Tetryonics, that is redefined, that square meters per second of Planck's constant is redefined as a triangle within a circle. 1 second, a spatial coordinate, is a circle. It's a measure of time, how much of a region you are measuring. The squared meters, as I illustrated in the previous picture, is simply the equilateral triangle. So if you were to draw a circle around this, you would have square meters, the equilateral triangle, per second, one circle. And in this case you would have two triangles in there, which represent a plus and a minus charge, but that's diverging from the topic. The only other thing remaining within Planck's constant is a measure of mass. So it's mass or kilograms per square meter, kilograms square meters per second. Must get it right so that I'm careful. Mass is a measure of energy. In fact, under Einstein's mass-energy equivalence, where mass is equated to energy, mass times the square of the speed of light, c squared, equals energy. So if you take a triangle of Planck's quanta and you take a unit of time, second, you have Planck's constant per second, which gives you energy. You could also just take the energy content per second and ignore the geometry. Energy divided by c squared, because that's what the circle would be, will give you mass. Mass energy equivalence under Einstein's E equals mc squared, where it should always be a lowercase m, is not the conversion of matter into mass energy. It is the conversion of matter into mass. Or more appropriately, it is the strict relationship of energy to what we measure it as per unit of time. E equals mc squared, or E divided by c squared equals m. energy per light second, c squared, equals mass. It's a direct relationship. It's not a conversion of one to the other. Mass is energy. If you take a snapshot of mass and freeze the system so there's no time changes, you are measuring energy in the system. If you measure that same system over 1 millisecond or 1 second or 1 year, you're introducing time, and then instead of measuring energy, you're measuring mass. But you can change between the two using E equals mc squared. It's been misinterpreted and poorly explained because in relativity there is no strict definition and differentiation between mass and matter. And in physics textbooks and in math textbooks, you'll rarely find any differentiation. They'll swap mass and matter all the time. They'll say that mass of an object is the same as the matter of the object because the mass makes up the matter. But in fact, matter cannot make up mass. It's a one-way relationship. And it's not stressed and it's not explained to people. Here we're explaining it. So in the illustrations in Tetryonic geometry, you'll see equilateral triangles filled with or made up of smaller equilaterals, whether it's the triangle, smaller ones making the larger or the larger being divided into smaller, makes no difference. You'll find they have in the corners of the triangles a lowercase m, a p for linear momentum, and v squared. So mass, velocity, again mass, velocity squared is energy. So you can see that that triangle, just focusing on the red, would equate to a measurement of energy. It's not mass because there's no circle around it. We draw a circle around it, we then have mass. So in this case the drawing is actually saying we have a physical amount of energy, positive and negative, drawn there, which we can measure or equate back to mass once we have a measurement of time in there. Of course, mv squared for energy can be, or can have the square root taken of it. Mv, or momentum, linear momentum, mv is the square root of mv squared, obviously, because you're taking away just one of the velocity factors. And you find that within the equilateral triangle you don't only have squared numbers, but the central riser, the height of the equilateral triangle, are integers numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is just the start of the amazing math that comes out of this geometric arrangement of triangles. So level 1 is 1 squared. Level 2, 2 squared, because obviously the linear momentum, being the square root, is 2. So 2 squared is the amount of energy. So to create a force for a given mass of 2, say 2 meters per second, you need that mass by 2 meters per second squared. So you need to square it, and that equilateral geometry does it. We'll talk about why it hasn't been seen up until now. It's easy to visualize it as just an arrow pointing out from an object in the direction of its motion, exactly as it's drawn there. Imagine the omega being a proton and the p being the direction of motion. As you increase the energy from 1 through to say 81, you increase the square root linear momentum in direct proportion. So again, all these physical properties arise from an equilateral geometry instead of a circular one. In Tetryonics, obviously the smallest quantum of mass, energy, momenta as it's termed, is the Planck quantum. It's an equilateral triangle. It's the smallest. Its value is Planck's constant. And it's a coin, as it's termed, Q-U-I-O-N. On one side there is a positive charge, on the other side there is a negative charge. You can see here an orange arrow circulating in one direction and another one going in the opposite direction for the negative charged quantum. These quantums, by the way, will be found in textbooks. They're known as W plus bosons and W minus bosons. When Einstein formulated relativity and his work, he came across an oscillator when he was working on in conjunction with Max Planck on these things. He was working on photons. Max Planck was working on the smallest quantum of energy, which he called a quantum oscillator. And as you can see here, the energy drawn with these fluxes oscillates. It doesn't physically oscillate, again, another discussion, but electrically, if you think of winding up a coil of wire and leading it up with a battery where the E is for an electrical source and back down, the current that flows in that direction will create a south-north magnetic dipole. If you reverse the current by changing the battery or winding the coil the other way, you end up with a north-south dipole, the opposite. And in fact, as the essence of a quantum oscillator, an equilateral Planck coin fits the bill exactly. It has a plus charge and a minus charge, so it is the source of charge at the quantum level. You can see now at this point that instead of mass velocity and mass velocity squared, we have Planck's constant, because what Planck did was he took the energy of the spectral lines and he divided it by their frequency, and he got this value that kept popping up, which he called Planck's constant. It was a mathematical trick, and some scoffed at him at the time, but it remained nonetheless. It's defined as a quantum oscillator. They believe that the energy oscillates in one direction or the other, and it's led to a lot of discussion as to the nature, the very foundational nature of physics itself. And this is what Tetryonics gives us. It gives us this building block that we can then use to build all the mass, all the matter, and all the forces of our universe. The only thing that these triangles don't build is empty space in the first place. So we've taken the energy of a system. It may not be one, it may be a large amount of energy. It can be rotating in either way. It can be plus or minus charge, or it can be neutral. It makes no difference. We divide it by the frequency, which in this case happens to be v squared, as in nu squared, not v, probably an appropriate usage of the term, nu squared, and we get Planck's constant, which is showing us that this triangle is the essence of what's being formed. Because remember, I said a scalar energy will be made up of in a large number of smaller equilaterals, and that's what this v squared stands for. Planck wrote his formulation as E equals n h nu, and that's just a generic way of saying it is some number. It's not a specific number, it's some number. Turns out that the specific equation he should have used was E equals h nu squared. That would have probably given a hint to relate it back to mv squared or mc squared, and maybe this relationship with equilateral geometries and quantized angular momentum may have been discovered much, much earlier. and Tetryonics would have emerged a century ago. But nonetheless, Planck had his quantum, h nu. Einstein also had a quantum of light called the photon. His was not h nu, it was hf, because it was related to the frequency measured for the emission work, or the work to create a photoelectric emission. So, and here's where mathematics started to go awry, because it's often termed in physics that h nu is just as it's termed h frequency, or the frequency of Planck quanta. So that the word nu often gets exchanged for frequency, and obviously hf is frequency. So you'll often see h nu equations like, and I'll go to the next slide, you'll see equations like E equals h nu equals hf, and from there mathematics will pour out, and they'll manipulate the math, and they'll come up with various things, and they'll scratch their heads and wonder why things aren't quite making sense. What's wrong with saying h nu equals hf? Well, the problem with h nu equals hf is that h nu, a quantum, is a triangle. A photon, or W boson, is a triangle. A photon is a neutral particle that radiates in two directions from its source point, with electric and magnetic fields out of phase with each other. In fact, the photon is its own antiparticle. When you look closely at the work, you find that bosons being a single triangle and photons being a dual triangle, in order to be neutralized and propagate in two directions at once, you cannot relate h nu to hf. You can say n h nu equals hf if and only if nh nu happens to be an even number, because you need an even number, otherwise you end up with an odd number and you have a boson left over in the equation. In fact, all of this was known to Einstein when he brought up the term zero-point energy, Nullpunkt Energies, in his paper, because he stated quite clearly that the energy for the simple harmonic oscillator of frequency f is, look at that, a half hf. Half of a diamond is nu, h nu. So h nu does not equal hf. To say that they do is mathematically the same as saying 1 equals 2, or 2 equals 1 in this case, or odds equals evens. Why odds equals evens? Well, I'll go a bit further into it now. Tetryonics, this is the integer learning part of Tetryonics. This is how we just break down the basic numbers for mathematics. We get a triangle and we break it up into a series of numbers, usually in accounting fashion. 1, 2, 3, 4, 5, 6, 7, 8. You can rearrange, of course, in any direction that you want, up and down, sideways. In this case, we're counting transversely, because remember the height determines the linear momentum, so that would be the direction of motion in this direction. So these end up being square root numbers. These are your squared numbers. So as you count across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on. So any triangle can be broken down into n number of quantum oscillators, or n Planck quanta, hence n in this illustration. And that is just an integer. That is as small a piece of energy or mass or anything that you can have in the universe. These are the smallest chunks, the very building blocks of everything. So the integers, and they can be numbered anyway, as I said, are simply the numbering pattern of each and every triangle within a larger triangle. From there, we quickly note, well, I did at least, if you follow the color coding there, that the first line has 1, the second line has 1, 2, 3, the third line 1, 2, 3, 4, 5. Every line in an equilateral triangle or a scalar triangle of energy, every transverse line is an odd number. There's 3 triangles in that energy level, 5 triangles in the yellow energy level, 7 Planck quanta in the green energy level, 9 Planck quanta in the aqua energy level, and so on, so forth. Mathematically, odd numbers are known as 2n minus 1, or they can also be expressed as 2n plus 1. For the purposes of this, most of the time you'd say if you start at 0, you use this, 2n plus 1. It makes no real difference. It does have a big impact later on when we start talking about acceleration, increasing energies and energy momenta, and deceleration, minus 1, taking energy out of a system to slow it down. Because, again, energy is always found in equilateral geometries, squared numbers. To go from one energy level to the next, you have to remove a precise amount. Einstein's photoelectric work proves this. You have to remove exactly the right amount of energy to go from one level to the other, because you must start with an equilateral triangle and you must end with an equilateral triangle. What the energy that you release, what it forms, whether it's bosons and photons, ones or evens or odds, makes no difference. But odd numbers are defined as 2n plus 1 or 2n minus 1, and they make up the levels, the quantum levels that you hear so much about, quantum level jumps, etc., transitions in quantum levels from one energy level to the other. This is all they are, the addition and subtraction of triangles of energy from a larger triangle. Of course, as you can see here, 2n minus 1 could have been plus 1, could have been minus 1, makes no difference. Those numbers, 1, 3, 5, 7, 9, following that formula for odd numbers, are listed as a methodology down the left-hand side of the triangle. Can go either side. There's some work by Anastasis Kircher, I think I got his first name right, in 1650, around the time of Newton, who drew up a rather similar arrangement to this, complete with linear momentum, energy, etc., and was promptly ignored because at the time just so happened that Newton brought out calculus along with Leibniz, and he also explained gravity. So Kircher's work was promptly not pushed aside, but promptly just forgotten. Kirchner was known as, incidentally, one of the last great polymaths. But back to this story, to get an n squared, or a scalar energy, which must always be a squared number, we simply add. 1 plus 3 gives us 4. So we're summing the odd numbers. 1 plus 3 plus 5 gives us 9. 9 plus 7, 16. 16 plus 9 plus 11, 36. So on. You can mix them up, chop and change as much as you want. Changing between or releasing or adding odd numbers to a equilateral energy is in fact how you make all the spectral colors. All the transitions of energy or electrons with energy in the atoms that give us the colors of the universe are all the result of adding and removing these odd number W bosons. Because remember, odd numbers represent a plus or a minus charge. 1 is an odd number, 3 is an odd number. So trapezoidal shapes, all odd numbers, all quantum levels, and specific numbers go together. You can't just bring 11 and 7 together because they're too big. You'd have to release 2 of them. You'd have a photon break away and would form a lower energy scalar. That illustration I've just shown you of the scalar energies, just to highlight a point, and the quantum levels, odd number bosons, can also be looked at for the same energies. These are the bosons that make up that energy, that scalar equilateral squared number energy, and they're odd numbers. You can also look at them in pairs, and a pair of bosons is a photon, which would obviously have the formula 2n, or 2 nu if you're talking Planck's quantum, which equals Planck's hf, Planck's constant times f, the frequency of the photon. So if you look at it in groups of 2, you then find, instead of looking from left to right or right to left, depending on which is your preference, you end up looking from top to bottom or bottom to top, whatever suits. And you find that these, in Tetryonics, I call longitudinal measurements. They're collinear with the direction of motion, because the linear momentum's this direction, and it's always the apex of the triangle points in the direction of motion. Simple as that. It doesn't matter if you rotate this around and this was the V, you would still have the same geometry as you did this way. But one direction must be always the direction of motion. Simple as that. So subdividing that same scalar energy up into the photons, you quickly find that, and it's a 50-50 chance, you end up with these bosons, or half wavelength photons at the bottom, because they have a diamond shape within an equilateral triangle. They will never completely fit in. So if you were to remove all the even numbered photons from a field of energy, you'd be left with the bosons that form the bottom highest energy levels. And bear in mind, none of these have any higher energy than the other. They're all identical in energy. They're all Planck's constant. So they all have exactly the same amount of energy. But it's when they come together via their charges, plus and minus, that they form the larger energies. And then as you get more energy, or more quanta in that triangle, the large scalar field, the linear momentum increases. The numbers go 1, 2, the square root again, gets higher and higher. And acceleration is a measure of changing linear momentum. You take energy out of the system, there's less linear momentum, it slows down. You add energy, 2n plus 1, you increase the linear momentum, you can increase the acceleration, etc. This is all that's going on, but this is how I would typically take a scalar field of energy and illustrate the photons, the two the dual boson arrangements within that field. And this becomes critically important down the track, because this even number arrangement, mirroring that they're photons, actually gives us the quantum probabilities that you see in physics, or in quantum physics throughout the place. They're not quantum fuzziness, they're not energy popping in and out, they are triangles of energy. What gives them the probability features is the distribution of energy. 1, 2, 1, 2, 3, 1, 2, 3, 4, and we'll discuss this a little bit later on. but the photons in a field are distributed in such a way that the energy creates a distribution, a normal distribution panel. It follows this curve like that, although it is more pronounced and sharp because we're making this curve out of triangles. I hope this noise isn't creating too much problems at the other end. To highlight the square root linear momentum, I've highlighted the photons that make up the square root of the scalar energy. N squared for the scalar energy. You can see the squared numbers along the right hand side, and you can quickly count the squared numbers. You can quickly count the odd numbers that make up each and every energy level. Interesting fact about the square roots of scalar energies is that they can be either positive or negative. Now, for mathematicians, this is going to blow some of their minds if they hear the comment and focus on it. In Tetryonics, we can show a physical answer to the square root of -1. It's an imaginary number in pure mathematics. It has no solution because any number you multiply will come out as a positive, being squared. So it's an abstract thought. But strangely enough, through the work of Euler and the others who introduced it, what they didn't realize at the time, because they were focusing on circular geometries, etc., and squared numbers, was the fact, unit circles, was the fact that if you use equilateral geometries, you can have a triangle, as we've said before. The full scalar energy can be positive, and it can also be negative. In both cases, the scalar energy has a square root linear momentum. So this linear momentum is the square root of both positive charges and negative charges. So now we have a physical explanation for Euler's identity. And in fact, it's elaborated in my QED books for those that want to go look at it. Or if anyone wants to message me on the topic, I'm happy to elaborate further and show you how Euler's equation and its beauty and simplicity, and the fact it involves all these other mathematical properties and attributes, is in fact a mathematical description of an electromagnetic wave. The sine and cosine are the electric and magnetic fields changing as the equilateral field propagates outwards. Unbeknownst to him, obviously, he was working in pure math, and it's now taken, I don't know how many centuries since he wrote his treatise, but now we have an explanation for the beauty. He's describing nature, the electromagnetic properties and field relationships of E and M fields, photons within an electromagnetic wave as it propagates. This would have been prior to Maxwell. So in effect, had he realized that you could use triangles and known a bit more, he would have no doubt recognized what I've done here and realized that his equation describes an electromagnetic field, and we would have had unification on the electromagnetic field way ahead of Maxwell. But that's history, as they say. As I said, the vector forces of this square root linear momentum is sine 60, obviously, because it's an equilateral triangle where all the angles are 60. So the height of the equilateral triangle, or the square root of the linear momentum, is sine 60 with respect to the length of the side. Square root of 3 on 2, sine 60. That's an irrational number. But now that we've defined that the square root of -1, which is the square root of a negative charge, the linear momentum of the negative charge, is a physical thing, we can indeed square it. And squaring it is basically just defining the charge. The square root squared then becomes the negative charge. I squared, square root of -1 squared equals -1. So all of a sudden, all the higher mathematics that Euler and the rest were, and Gauss were playing around with, can be easily represented without the need to explain the math or go into a lot of the complex ideas. Things like pi. Pi itself being a circular relationship between the circumference and the diameter of a circle doesn't come up a lot in Tetryonics except for spatial coordinate systems. But if you think about it, an equilateral triangle does in fact map out pi radians, and that comes in when we talk about charged topologies of matter. I often refer to a charge, in this case a negative charge as drawn here, as pi radians. It would technically have to have a curve here, and I'm sure the pure mathematicians are now saying it needs that curve there to be pi radians, etc. But it's still pi, because I did a lot of research on it. There is a treaty written up between Gauss-Bonnet, I think it's called the Gauss-Bonnet theorem, where the curved topology of a sphere, 4 pi sphere, was related back to and equated to a 4 pi tetrahedra, which means the 4 pi tetrahedra is the same thing as a 4 pi sphere. So I'm quite able to term each charged face or each charge as pi. And if you bring 4 of these triangles of energy together to form a tetrahedron, it would be 4 pi charged faces making up that tetrahedron. And again, where the irrational numbers pop up from, 99.99% of the time, when you see an irrational number in physics, it's the result of a force, the result of linear momentum acting on something, causing it to move or decelerating it, accelerations, decelerations, etc. So this square root, which starts off irrational itself, which is the height of the scalar energy, is what gives us these irrational numbers that pop up all through quantum mechanics. So we can bring all these relationships, the square roots, the scalar squared energies, the transverse charge bosons, the quantum levels, odd numbers, even numbers where they come together in pairs to form a normal distribution pattern. All the aspects of maths, including zero itself, a 0 point. It's quite well defined in the geometry. And the fact that there are positive numbers, positive charges, and negative charges radiating from a central point can give us a clear definition of a numbering system as it's used in maths. Positive, negative numbers, imaginary numbers, irrational numbers, odds, evens, squares, integers, they're all included in Tetryonic geometrics. So we can begin to relate all these things back into the mathematics that's out there at present, trying to attempt to explain various fields of science and either not agreeing with other fields or coming up with impossible conundrums of their own within their own field. I, of course, amalgamate all this information back into a single diagram, and this is the one you'll see most often, apart from the one where instead of odds I show even photons going the other way. Again, transverse bosons versus longitudinal photons, odds versus evens, 1 versus 2. Same thing, square root linear momentum, creating force, any number at all, where odd numbers sum up to create squared numbers, and the difference between squared numbers, any two adjacent squared numbers, is an odd number. And with respect to even numbers distribution within the scalar equilateral energy field, the even number distribution forms a normal or bell curve distribution. 1, 2, well, I'm counting bosons here, so they're halves, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Sometimes I'll show them as half, bosons as half, and the photons as a full. Sometimes I show the bosons as 1, photons as 2, 3, 4, as I counted just then. Interesting point, if you take 81 divided by 80, which is the energy you need to release from this energy level, if you had a photon, an electron at this energy level, and it needed to go down to the lowest possible energy level, it would have to release all this energy here. If you did that, you would actually come up with a ratio, 80 divided by 81, of 0.987654321, which again, of course, as no doubt you can see, reflects the integer numbering of the square roots of this triangle. Like I said, a lot of the existing mathematical principles can be reinterpreted geometrically from the existing math into, with circles and squares, into this equilateral form. And in doing so, we can then replace the word one or scalar or things like that with charge, energy, mass, matter, etc. And all these features come through. Of course, I've color coded these numbers. 1 is red, 2 is orange, 3 is yellow, and these are in accord with the spectral colors that come out of a prism. With the exception of the normal text, I've put in aqua, and I put aqua in there because it's important to differentiate between the green and the blue. And light blue had already been taken up with magnetic fields, as a particular green had as well. So color coding makes it difficult in some respects, but it allows you to see the quantum numbers very quickly. And when you color code, that's odd numbers, obviously. When you color code for even numbers, you can see the color code changes immediately in the direction of longitudinal propagation. So photons, bosons, transverse mass, longitudinal mass, which is how it used to be termed pre-relativity. There was talk of transverse masses because of measurements with Ampere's law, etc. And then there was longitudinal masses due to acceleration of particles, etc., in linear accelerators. But all that information can be brought back into that one illustration where I'm talking bosons. I tend to put an N. You could have a W if you so wished, but I normally use N because it's usually a generic illustration of the math. But when I talk photons, I show it as a wave function, and it's done that way because of this distribution that it forms, and that's particularly important in things like wave-particle duality and interference patterns. That's what creates all those bars of interference patterns, etc. So I term that the wave function view. Again, doesn't change the odds on the outside, the evens along the bottom, and the squares or equilateral numbers on the right hand side, and integer square roots in the middle. They're all components of the same illustration depending on how you look at it. And that arrangement can be rearranged in a number of ways. I won't labour on too much more here, but you can rearrange the numbering and the colour coding of integers to give you triangular numbers looking in a longitudinal manner. 1, 1 and 2 is 3, 1, 2, 3 is 6, etc. For longitudinal, you want to get more larger triangular numbers, make a bigger triangle. And interestingly enough, twin triangular numbers sum up to a squared number. 15 and 21, 10 and 15, 6 and 10, all these numbers with the levels come together to form squared numbers, and they follow a mathematical formula, just like all the other math discoveries do. Equilateral triangles also have an interesting property, another one, and that is that they're scalable. You can take an equilateral triangle and you can double it, triple it, make it 1,000,000 times bigger, and it's still exactly the same proportions, just like a circle. And in fact, you can draw a circle and put an equilateral triangle inside it, and inside that triangle you can inscribe another circle, and it's exactly half. So the constant of proportionality between one circle and another that's a quarter its size is an equilateral triangle. That's covered more in my math book. I haven't covered it in this lecture because it's not necessary. But what it does tell you is that you can scale and use it as an exponential scale. It's not only exponentially scalable, but it's also a constant proportion. So when you hear Planck's constant, it's constant because of the equilateral form of omega, the quantized angular momentum. The equilateral geometry is what makes Planck's constant. It's not the math. Nature doesn't care less about the math that you're seeing here and that I'm explaining, or that are in the textbooks. Richard Feynman put it best: there is no electron out there that knows where the other one is, yet they behave as though they do. They are certainly not supercomputers doing their calculations with the force equations to work out where each and every particle is of every charge in the universe at any given time, because Coulomb's equations are time independent. They're certainly not doing quantum calculations to determine the forces and locations of all the particles in order to know which way to move. None of that is happening. What is happening is that the equilateral geometry is how nature works. The fields, equilateral fields of energy, momenta, charge, spread out are generated at a point, spread out from a point, reach across space, and then two fields interact as per Coulomb's law. They interact and they create action and reaction as per Newton's laws. And here's Newton and Coulomb's equations rewritten. No circles for the squared numbers, no spherical packing, no cubic packing, no squares for squared numbers, using equilateral geometries to create equilateral numbers, if you like, in physics. We can see the relationships of mass velocity squared, mass velocity for momenta in the center. We see mass omega, which is Planck's constant, and energy, the number of Planck quanta, per c squared, E divided by, or number of Planck quanta is the energy. Energy divided by c squared is the mass of the system. All that information's in there. What's been missing is, firstly, the equilateral geometry and an understanding that that's what squared numbers explain, and then applying that to Planck's constant to realize that the quantized angular momentum of Planck's constant is the source, is this hidden constant. It's the hidden equilateral triangle, the shape of the energy, that allows it to have a charge, that allows it to form larger squared number fields of energy with associated linear momentum, square roots, to have positive and negative charge. And for those fields to reach out, a triangular field like this reaches out from one charge to another. So just extend that up there. That's just the electric component. See how a big triangle of charge has an electric diamond-shaped component. That diamond-shaped positive charge, if it may be, reaches out to that charge. It might be negative, it might be positive. And that charge reaches back. Where they overlap, that creates the force between the two charges. It's two fields of mass, energy, momenta, acting and reacting, pushing and pulling between the particles. No math, simple geometric fields of energy that are acting between the two particles in a region of space. That gives us Rydberg's formulas, that gives us the speed of light, gives us electric and magnetic fields, gives us Coulomb's equation. And if you look at that, Q1, Q2, with a constant of K, which is an inverse square of the distance between them. And when you look over here, you can see the same thing for Newton's equation. Same thing, time independent, but instead of charge with a K constant, it's matter with a gravitational constant, or mass as some people may call it, but it's not, it's matter. You'll note in Tetryonics, I always write matter with a capital M and mass with a lowercase m. Mass here, lowercase m. In this case, in this illustration down here, I've drawn a tetrahedra. Hard to draw in 2D, but where you see an equilateral with lines coming in to meet at the center, that represents a polar view of a tetrahedra. And in that case, because it's a tetrahedra topology made up of 4 mass fields or mass energy fields, it's a quantum of matter. And in fact, that quantum has a name. Its name is a tetryon, hence the name Tetryonic theory, because Tetryonic theory is all about differentiating mass from matter. The tetryon is a hitherto unknown quantum subatomic particle. There are 3 of them in electrons. There are 3 of them in quarks. There are 9 of them in protons and neutrons. But it is those tetrahedral quantum, the tetryons, charged tetryons, that come together to create all the matter. And the reason why they're solid has nothing to do with the repulsion of negative charged electrons in each piece of matter. Pure bunkum. The reason why matter is solid and tangible and can be touched as opposed to a field of energy or radio waves is because it's made up of these tetrahedra. They are physical topologies. When I use the word topology, I mean something that has sides on it, like a tetrahedra, that has encloses a volume and keeps the outside from the inside of that volume. So matter is a topology, or has a topology. Mass does not. Mass is a planar geometry. It is flat. It's like, and there'll be people that want to argue about this, but it is like a sheet of paper versus a folded up sheet of paper to make a tetrahedra. That's why the templates are so useful in learning Tetryonics, because with those templates you can make models of all this, and you can begin to see how these fields overlap and the difference between mass, energy and matter. You can become more and more familiar with all the terms that I'm using as we go through, and quite possibly create some more of your own. Your own understanding, particularly if you've been trained mathematically or in physics, will change. Let me assure you, I'm trained as an electrical engineer and my understanding has changed. The math is like a language. The math is like Latin but you don't know what the people who wrote the Latin are trying to describe. It's like a dead language. You can manipulate it, you can do things, but just because you can make up a word does not mean that word has any legitimacy. Just because you think you can then string those words into a sentence, supposedly, does not make that sentence right. And that's what we're doing wrong with the math of modern physics. We don't have a physical, tangible model on which to test the mathematics. We need a model that agrees with the known observables, can build models of mass and matter and physical forces that explains what we observe and allows us to test the mathematical treaties and the mathematical assumptions. And that's where Tetryonics stands out, because by using equilaterals and omega, I've gone through all the fields of science and united them and done away with a whole lot of the assumptions, the black holes, the wormholes, singularities, fusion, all these sorts of things where there is no basis other than a mathematical possibility that it may work, while ignoring some of the parts of the theory that say it can't. All that gets swept aside and we say, what can we do with the physical model? What can we do? So instead of a language, we now have physical models of what that language is describing, with which to check the sentences, check the grammar, see what is and is not permissible, and to explain and increase our own understanding as we develop a better comprehension of what's going on. And I hope I've gotten through that the basics, that in physics squared numbers, particularly Planck, where energy and mass is concerned, are in fact triangles of energy momenta. And I hope as you follow through and see more and more examples of what Tetryonics can explain, as opposed to the modern texts and what's being taught now, you will come to the same conclusion over time that I did as I continue to develop and refine my own work. No longer do we have to have an idea that you need mathematics in order to understand physics. In fact, mathematics is just an emergent property of physics, and particularly of the geometry of nature. A geometry we haven't known until now. Now that we know it, we can reorganize quite a number of things. You can see in this illustration, rather whimsically, I just changed the squares of the Pythagorean theorem of a squared plus b squared equals c squared, which everybody learns and everybody sees explained like this. I show that you can do the same thing by explaining them with equilateral triangles. A equilateral plus b equilateral equals c equilateral, which gives you, funnily enough, in a case of a right-angled triangle, half an equilateral triangle. Right-angled triangles are half equilaterals. This is where physics has been going wrong. Physics, in attempting to describe energy and the relationship between mv squared and velocity, etc., have applied those formulas, mv squared, scalar energy, mass, to right-angled triangles, as you can see illustrated here. For potential mass, kinetic energies, etc. They're trying to explain the energy in terms of a right-angled triangle. And in doing so, you come up with crazy notions like you can only go as fast as the speed of light. Or, worse still, that photons made up of energy and hence have mass and momentum are called massless particles. A, they have energy, so energy per second is mass. They're not massless. B, they have momentum. Momentum is defined as m, mass velocity. To have momentum, they must have mass. Any textbook that you see or any professor you see that attempts to dissuade you of that fact is politely talking out of his own hat. Once you have energy, you can have a mass equivalence. The problem they're coming into relates to relativity. The speed of light is a limit, and using the wrong underlying geometry. Nature does not use right-angled triangles of energy. It uses equilateral triangles of energy with square root linear momentum that creates a force. Change the energy content of this triangle, you change the linear momentum. Changing the linear momentum over time results in an acceleration, F equals ma. All these things, massless particles, that's the other thing. Under the Tetryonic definition, in order to be a particle, you must have a topology. You're a piece of matter. A particle is a piece of matter. Photons are only 2D sheets of mass energy momenta. So the more appropriate term for a photon would be a matterless particle. A matterless field will be the best. And that's why when I see right-angled triangles attempting to explain energy momenta relationships, I call them half-truths. Because quite literally, the right-angled triangle is half of the equilateral. So just to try and round this off and cap it up, because we are going well over what I wanted to set myself. We've spoken about the 0-point fields, 0-point energy, spoken of by Einstein. We've shown that an equilateral quantum, mass omega, a number of them make up energy, mass omega being Planck's constant, and that each triangle is a W boson, and that two bosons, plus and minus, coming together form a photon with an energy equal to its, or proportional to its frequency. You can have two pluses coming together, by the way, two negatives. They form electrostatic fields, not electromagnetic. You can see that mass, planar mass, is quite distinct from matter, topological matter. One is measured, and both are forms of energy. Energy makes up mass, energy makes up matter. They have linear momentum, they have electric and magnetic charges, but they are equilateral. That's what the omega in Planck's constant up here is all about. Mass omega, Planck's constant, H. In Tetryonics, we call energy per second as a mass, and we refer to them as 2D planar or Euclidean geometries. Whereas matter that has form, a topological shape, is a 3D matter topology. And when you understand the difference between mass and matter, as you'll see here, Einstein's equation of E equals mc squared has to be changed to include matter, which is capital M by c to the fourth. Funnily enough, when you use that equation, not only does E equals mc squared, or energy equals mass c squared, but matter, capital M, also equals mc squared. So it can get very confusing. Einstein had the easy part. He only had one half of the equation. He ignored mass. He didn't ignore it. He converted everything into energy, stress energy tensors, irrespective of the geometry. The geometry, the topology of a piece of matter, of a tetryon upwards, is crucial to understanding gravity. If you don't make the models, don't be surprised if you have trouble differentiating gravity from gravitation. It will happen. You need to make the models. Odd numbers, or trapezoidal shapes, quantum levels, are W bosons. They're a transverse measure of mass energy momenta. They're charges. Photons, even numbers, are longitudinal measurements of mass, energy, momenta, and they form a normal distribution or a bell curve, which, despite Bell's own theory, can now be shown as a physical reality. It does physically exist. Things like particle indeterminacy or quantum fuzziness that stems directly from this probability curve are now shown to be wrong. There is nothing fuzzy or indeterminate about that arrangement. That is exactly what exists. And if you had a piece of matter, it would be sitting in the middle there. What you're measuring with a probability is the likelihood of finding a quantum or a Planck triangle at a certain distance from the center of the particle. The further out you go, the less likely you are to find a triangle of energy. The closer in you go, the more likely or the more triangles you will find. The maximum amount of triangles coincides with the linear momentum of the particle, the direction, and points in the direction of its motion. Nature's a wonderful thing. We've shown that square roots can equally be explained, as I just did there. They're always highlighted in pink, by the way. Sometimes with a pink arrow. Sometimes I fill in the photons themselves in pink, because pink's not part of the spectral color series that I normally use. So it does stand out and highlight the vector force or the vector direction. And of course, being a vector direction of a scalar energy, we can have the square root of 1 and the square root of -1. Square root of a positive charge, square root of a negative charge, in a very real, tangible way. We can represent all the numbering systems, all the wave functions of quantum mechanics, explain all the distributions, the inherent unknowingness. We can show what 0 points are, what singularities are. We can show what imaginary numbers are. We can show the phase relationships of longitudinal and transverse EM waves, as well as longitudinal and transverse energy momenta within those waves. And those waves, being geometrically equilateral, are scalable. They go from 1 to any number you choose. So in fact, you can go from 1 here and scale up the triangle to a linear momentum value of infinity, and you would actually have an energy level of infinity squared. So 1 to infinity squared, or 1 to any number you choose squared. But within that geometry, this side will always be odd numbers. This side will always be squared numbers. It will always form a normal distribution of mass, energy, momenta, with the amplitude equating to the linear momentum, or the highest peak value force of that system of mass, energy, momenta. So all these quantum properties that are described by the math are there for the picking in the geometries. Nothing complex. And in fact, if you color code all the triangles, you can see that where we originally described clockwise positive circulations and anti-clockwise negative charge circulations, we can now explain spin, flux, EM flux, and electrical curl or magnetic curl at the quantum level. Spin, curl, flux, all names for this rotation of energy, which in fact is not a vector rotation of energy, despite it being omega. It is simply a square meter per second circle. 1 light second is c squared. Square meter or equilateral meter per light second. Measure of the energy, equilateral energy per second. That's all spin, curl, flux. So if you hear spin, curl, flux in quantum discussions with people, think an equilateral triangle. They won't, unless they read or heard Tetryonics. When these positive and negative, bearing in mind that all these triangles, the odd number triangles making up the transverse quantum levels, or the total mixture of positive and negative charges within the scalar equilateral energy, will either be positive or negative, and they always come together in the patterns shown here, where you have there's an imbalance, an inherent asymmetry, it's called, in the way that you can arrange positive and negative charges within an equilateral triangle. You only have a positive or a negative, there are no neutrals. So arranging the positive and the negative charges within an equilateral triangle, you end up either with positives on the outside and negatives on the inside, which makes it a positive charge, because the positive is what you detect, or you end up with negative on the outside with positive internalized, which makes it a negative charge so far as detection and measurement goes. You will always see the negative first before the positive. I'll go into discussions further about the fact that these positive and negative fields, just like Miles Mathis worked out in his work, have SI units of mass seconds, omega, quantized angular momentum, per c squared. If you write the units down, square meters per second by, or divided by, square meters per second squared gives you seconds. So Planck's constant divided by c squared is mass seconds. Mass seconds, seconds being a measure of time, measure of flux, change, curl, measure of rotation, is in fact charge at the quantum level. And this inability to make either an entirely positive or an entirely negative, or the imbalance, the broken symmetry, is a result of the asymmetric normal distribution of Planck quanta within scalar energies. And again, all this talk of spin, curl, vector rotation, angular momentum, none of it exists. The reality is an equilateral triangle, is giving us the impression that there is a spin or a curl or a flux going on. The arrangement of the equilateral geometry of energy itself and the way it comes together within larger scalar energy fields creates positive and negative charges and leads to the broken symmetry so necessary and often observed in physics experiments. It's an inherent part. What's so important about creating bigger and positive and negative charges from little charges, little quantum points? Well, that's how you make mass and matter. You have charged masses that then form, by the way, just to jump back, a equilateral field, which is h nu squared. Most bosons are h nu, because they're odd numbers, remember. A squared number can be either equal or odd, but it's always a squared number. So h nu squared is a unique boson. It's still a charge because of the way the charge distributions work out. It's always a charge. What's the uniqueness of a charge that's not h nu or odd h nu, but is a h nu squared? It's in fact what they term presently as a Higgs boson. Every piece of matter from the tetryon upwards has equilateral charged faces. Those charged faces have squared energy levels. As you form bigger and bigger chunks of matter, you form deuterium nuclei. First up, after protons and neutrons and electrons, they combine to form deuterium nuclei, and the number of quanta, h nu squared, in the charged face of those deuterium atoms, and these atoms will look strange to some people that haven't gone through the chemistry book yet, but we're working our way towards it, all have distinct squared energy levels. The energy level of the orange deuterium nuclei is 4 times that of the red one on the bottom. The yellow ones are 9 times the energy level of the red. Green, 16 times n squared, remember? These numbers here, the energy levels, n squared, are the ones that are familiar to those that have done work with electron orbitals or energy transitions in atoms, etc. N squared pops up everywhere as an electron jumps from one level down to another, or an electron's bound at one spot, light is shone on it and it jumps up to another level, or it jumps to break free completely and travel off, or it might come in, lose a bit of energy, lose a bit more, and then remain at that level. So there's various mechanisms, but all of them involve adding and releasing bosons or photons to the squared equilateral energy levels of these matter particles and the electrons with them. There's a whole mechanics that goes into how the electron gets its energy from the deuterium nuclei or the deuteron. I'll talk about that later on. But these are the n squared, which used to be described classically as atomic shells. Bohr described them as atomic shells. Schrödinger called them energy levels, n squared. He then wrote a wave equation to describe the orbitals and the suborbitals, all the possible transitions that Bohr had described in an atom, and he assigned numbers to them because Bohr was describing what he observed. Schrödinger and Heisenberg were describing the mathematics of what brought about what they observed. Tetryonics, with the geometry, can now draw a picture of the atom and relate shells to energy levels, orbitals and suborbitals to quantum numbers. And you can just map one to the other and you can see the relationship there in that particular illustration. So we go from a spherical model that Bohr had with an electron zooming around like a satellite to the mathematics of Schrödinger, which changes for each and every element and makes it near impossible for any mathematician to describe all the electron properties, the electron configuration of any given element above, say, 10 realistically, whereas Tetryonics can and has done described all those properties for each and every possible element up to element 120. So we've gone from the Bohr model further. We've gone from Dalton's plum pudding model to the Bohr model to Schrödinger's it's a fuzzy wave function, and we've got dumbbell-shaped orbitals that we can't define, to a physical model based on the charge topology of every single periodic atom that's out there, along with their complete electron configuration. And this, by the way, as you can see there, incorporates the Aufbau table as well. The deuterium nuclei all act as quantum synchronous converters. People that have done work with Tesla and Westinghouse or built an electrical motor would be familiar with how these work. The more energy they have, the faster the flywheel / electron spins. You get to a point with so much energy in the atom that the electron cannot remain bound and it breaks free. And that's the principle of energy transitions, of creating spectral lines, as I mentioned earlier. These transitions, again, are just equilateral fields of energy. These are the chem fields. Imagine an electron sitting here where the C is, Imagine an electron. It won't be a ball, but for the purposes, the electron's sitting there. As you add and remove bosons and photons from the equilateral scalar energies, as shown on the sides here, the energy changes for the chem field. Chem standing for kinetic electromagnetic field. It's got the kinetic energy plus the magnetic moment, or the magnetic dipole. Every particle in motion, particularly electrons, when they're standing still, have no kinetic energy, and they have no magnetic moment. They're an electrostatic field, no magnetic properties. The moment you give them energy of motion, a magnetic dipole, a magnetic moment appears. It's not caused by the squashing of the spherical electron as it moves. Nothing to do with it. Relativity is completely wrong, and I will talk at length to whoever would like to talk about it. The magnetic dipole appears because the energies of motion, the chem field, is created when the force is applied, and it has a magnetic moment. Add more energy, the magnetic moment gets stronger, as does the kinetic energy, and because it's an equilateral field, the linear momentum, because it's being pushed harder, increases, and the vector velocity increases as well. V on C, if you're talking relativity, V on C in relativity, the Lorentz linear correction is just this. What's the velocity out of C? How far can we go? The scalar, Lorentz scalar correction, V squared on C squared, is this one, relating the energy per second to the motion. They assume through relativity that C is the limit, but as we now know, this geometry is scalable, and infinitely so. We can in fact increase this triangle, or we can increase the number of quanta in that field to any amount. If we chose 4C Planck quanta, the resultant velocity would be 2C, bearing for whatever the mass is, just as an arbitrary number to point the example out. There is no limitations to stop at 1C. You can easily go to 2C, 4C, 100C. All you need is enough energy per unit of time to create that force and the motion. It's the geometry that lets us work this out. The math prevents us from working this out. The geometry reveals the errors and the incorrect assumptions that have grown in the language of math, because it hasn't got a proper geometric foundation with which to test its reality. This linear or Lorentz contraction is in fact none other than another way of saying the Rydberg wave number, increasing the number of Planck quanta, the wave number, inverse of frequency, of the number of Planck quanta in any field of a photoelectron. There's the electron pictured there, as I said. It's matter. The chem field has a kinetic field, diamond shaped, because it's made of photons. It's a photon one. And it has a magnetic dipole. It's an electromagnetic field. It'll have a velocity between V and C, for argument's sake. We know it can go faster now, given the right amount of energy and the right form of energy. And Rydberg's formulation for it, the inverse of the wavelength, over here, is the difference of what? Inverse difference of two squares. 1 over Ni minus 1 over Nf, being initial energy, final energy, depending on whether the electron is being accelerated from the nuclei, being emitted, or whether it's being absorbed. Depends whether that's I and that's F, or that's F and that's I. No difference. It still remains the difference of two squares, We know the squared numbers are there. All we're doing is adding and removing energy levels, bosons, from the scalar energy. N or 2n minus 1 to remove the energies, 2n plus 1 to add the energies, and the 2n must always be the odd number that's required to go to the next level or the next number of levels. You might put 2 energy levels in at once to make it jump 2 energy levels, or to jump an energy level. But at the bottom of all this talk about squared numbers and squared equilateral energies and acceleration, deceleration, it's just a difference. Delta H nu. The removal or the addition, the change in the amount of Planck quanta, equilateral triangles of energy in this field, is directly equated to the change of the object, matter, and its velocity. It's not mass velocity, it's matter velocity. You could say mass velocity so long as you're well aware of the difference. Matter has mass, mass does not have matter. Yet another discussion to be had some other time. But changing the energy results in a change of linear momentum. Delta HV changes energy, changes the scalar energy, which changes the square root linear momentum. And I call that a spectral line differential. And if you look in the QED ebooks, you will see I have done detailed illustrations of these transitions with the resultant frequency numbers, the whole lot, for each and every possible spectral line that is possible in nature, for every energy level, including one that is currently unnamed because the math didn't go far enough to include it, but it's there now. So just to sum up, I think I've taken up enough time and we've gone far enough with this discussion. I certainly wanted to keep these down to shorter recordings, but such is the nature with a unified field theory. So many things interconnect. One thing leads to another. One thing needs an explanation of the other. Nature is interrelated on all energy levels. It's very hard to focus down onto specific topics, but I shall endeavour to do that in the lectures to come. But to sum up, I hope you can now look at this illustration that you see there and realize the importance of omega, which you find throughout Tetryonic theory, and know instantly now that mass omega is Planck's constant, kilograms square meters per second, and that when you do work in theoretical work or in physics work somewhere else, that you at least take away the understanding that mass omega, that there is a geometry to Planck's constant. It's the geometry that gives us the constants of proportionality, the relationship between energy, linear momentum, mass and energy, velocity and force, changes of energy and acceleration. All these things are interrelated via the equilateral geometry. As I said at the beginning, if you want to disprove Tetryonic theory, all you have to do is show me a geometry that relates to square meters per second to angular momentum, that you can then do what I do with Tetryonics and unify chemistry, physics, biology, electrical theory, cosmology, maths and music. Pick any shape you want. I chose the equilateral triangle because it popped into my head, and it also happens to be the simplest form, but someone out there may be able to come up with something else. Some people say they have, and they've yet to produce the work in order to show that they've made a better Tetryonic theory. But remember, hexagonals don't count because they're made up of equilateral triangles. I hope you've enjoyed this. I hope I've certainly covered and explained things in a little bit more detail, and in a way where you can at least get familiar with the basic mathematical principles of Tetryonics. I'll continue the series obviously as time permits, And if you've got any suggestions you'd like covered, I'll try and work it in with the curriculum I have in mind, which basically follows the chapters of the ebooks, and we can develop a better explanation and a better exploration for all concerned. So thank you for your time. It's been much longer than I originally anticipated, but I hope you've gained from it all the same. All the best.